Hello everybody. Let's look into a very fun math problem. Okay? This is actually the boy-girl paradox, sometimes entitled that, and it states the following. I have two children. One is a boy born on a Tuesday. What is the probability I have two boys? Okay? And intuitively, right, this actually is very good portrayal of how intuition can sometimes fail us. Okay? Intuitively, it's 1/2, right? I mean, if there's a boy, I don't care when he was born, whatever, like the next one's going to be a boy or a girl, 50%, right? We're assuming there's 50% chance of a boy, 50% chance of a girl, which is okay. But then, is it actually the probability of the second one being a boy given the first one is a boy? Is it actually let's see, is it actually equal to 1/2? Okay, because well, actually, this may be, this is equal to 1/2. Let's do this problem. But did anywhere there I say, or did the problem state that the first one or the second one was born on Tuesday or is a boy, right? Let's see. So forget the Tuesday part for now. Tuesday will matter a lot, but let's just say we were doing this problem. Well, this is not going to be the correct answer, okay? Because this is a different problem. This is again saying that the first one is a boy. Let's see. So let's try to solve this one. Let's actually assume, that we're given the first one's a boy. So what if first one is boy on Tuesday, which is not this problem. Remember, this is not saying the first one, okay? It can be any of them, okay? So if we're talking about this case, okay, case here, then what we can do is this. We can say, well, what's the probability? Let's do a little diagram like this. What's the probability that we have boy 1 that's born on Tuesday and boy 2 can be born on any day, right? And we're given, of course, that boy 1 is born on Tuesday, okay? That's what we're given. Let's do it that way. And that's equal to the total number of successful outcomes, right, over the total number of possible outcomes that we are able to use. So successful outcomes, in other words, look, there are basically this any is 7, right? There's going to be boy 1 on Tuesday, boy 2 any number of days. So we have 7 possibilities on the top. It can be Monday, Tuesday, all the way to Sunday, divided by, well, if boy 1's on Tuesday, the other one can be what? A boy on any day or a girl any day. So it's going to be 7 plus 7, right? Depending on boy or girl. And that's going to equal to, one second, let me make it a little neater here. Okay, that's going to be equal to 7 over 14 equal to 1/2. Okay, great, we're done. Unfortunately, this is not the answer for this problem. It's incorrect. And let's see why. Again, I've mentioned that we are not given this idea of order of basically the first one having to be a boy. It just says one of them is a boy, right? And what's the chance that the other one is also a boy? It's kind of tricky. It's a different problem. It's very interesting here. So let me show you another technique, what we could have done, another approach. We could have said, look, what if we're getting that any of them is a boy? So any one of them is a boy, okay? So here I'm saying basically order doesn't really matter at all, okay? And I just want to know, what's the chance that if any of them that there is a boy, right? If that's the case, if let's say we do not have anything having to do with Tuesday, anything like that, anything a little bit more descriptive, specific, then what would that do for us? Let's see. What's the probability that we have? So this is less intuitive, right? Insightfully, we would say 1/2. It's incorrect for this problem, okay? Now look, what if we did this? Well, we have to have both boys, right? Boy, boy. We're given that it's basically what? it's not a girl-girl scenario, right? One of them can be a boy. So, in other words, not, let's say not girl-girl to make it easier for ourselves, less writing. Okay. Again, why? Because there are cases of boy-boy, right? Boy-girl, girl-boy, and girl-girl, right? So this is, I mean, it depends on whether you have a boy and then a boy, or then a boy-girl, a girl-boy, or girl-girl, right? There are four possibilities. Like for example, if you just asked in a life scenario, oh, here are this person has 2 children. What's the chance there's a boy and a girl? Yes, the answer will be 2/4 or 1/2. Yes, that's true. But that's not, for example, anything relevant to this problem necessarily. Because look at this. The probability, this one would be what? It's going to be, well, boy, boy, there's just one of them, right? And here are the ones that have no girl. In other words, somewhere there's a boy, 1/3, right? And for this one, if I told you, you have there's a boy, it has to be a boy there. What's the chance that both of them are boys? Yes, that would be 1/3, okay? And that's very different, right? This is not saying the first one, anything, okay? Very tricky there. And this is actually not insightful. This is also incorrect. So what is correct? Well, what we're going to do is we're going to do what the problem told us. It said, look, there's anyone is a boy born on a Tuesday, okay? So one of them, let's say, one of them, and is boy born on Tuesday, born on Tuesday, okay? Let me just write Tuesday. Now this is the problem that we're trying to solve, okay? That's the one. That's the one. So what we can do here is we're basically wondering what's the probability that we're going to have a boy, right? Let me write this way. 1 second. That we're going to have a boy and a boy and at least one, so at least one born on Tuesday. Okay, let me just go down here 1 second. At least one. Let me do this here. At least one. So we're trying to see if there's a boy and boy and at least one born Tuesday. Okay. Tuesday. Given that at least one, right? At least one is a boy. There's a boy, 1 second. There's a boy born on Tuesday. Okay? Well, this one, it has some cases to it. Okay? Here's what happens. Let's break it down into, let's put order into this. Let's make sure, order matters. So, what if we had, let me show you this. What if we had, okay, what if the first one's a boy, okay? I mean, first one is the boy, born on Tuesday. And then the second one, well, what if that's also a boy, because we're looking for boy, right? So boy 2, but now and he's also born on Tuesday. Okay, and you're given again that boy, that this is just, there's a boy on a Tuesday, okay? And then that's one possibility, right? There's also, we have to also add that to the probability that we would have had boy 1 on Tuesday, right? And boy 2 on not Tuesday, right? That's possible. It's a completely different, right, disjoint thing. And then we have boy Tuesday, some boy, some Tuesday. Okay, we have to look into actually this boy Tuesday. How many possibilities for that are there, right? How many outcomes are there for just having a boy Tuesday moment? One of them being a boy on a Tuesday. And the other probability that we'll have to look into and add them all up is this one. That you have to have a boy 1 that's not Tuesday this time, okay? And then boy 2 is the Tuesday one, okay? And then you're given, of course, this one of them is a boy on a Tuesday, okay? So first, here's what we have to do. But let's go down here for a moment. It's just total possible number of outcomes. Possible number outcomes for this BT, Boy Tuesday, right? It's basically, let's actually call it N, possible number outcomes, just to remember this right here. Let me kind of do that, and then, give me 1 second. So let me put a little N in front of it. Okay, so this N of this BT, the Boy Tuesday moment, would be basically the number of that you have a boy, 1, Tuesday, and then anything else goes. So let's say boy, right, so let's say you have girl any day, right? Or we could have maybe that it's girl any day and boy 2 is a Tuesday one, okay? Or if we're 2 boys, we're talking about 2 boys, we have a lot of things going on. We could have boy 1 Tuesday, boy 2 Tuesday, right? Or we could have, just like we did above there, boy 1 Tuesday, but boy 2 is not a Tuesday boy, okay? And finally, that boy 1 is not a Tuesday boy, and boy 2 is a Tuesday boy, okay? And so now look, what this is going to give us is, well, how many are there? This any basically gives away that there's 7, right? Possibilities for this. Boy 1 Tuesday, girl can be anything. This is 7. Now, what about boy 1 Tuesday, boy 1 Tuesday? That's just one possibility, right? That's just one. And then how many are there these non-Tuesday days? So you're basically only looking at about, if there's a Tuesday, the other one can be Monday, Wednesday, Thursday, Friday, Saturday, Sunday. So 6 possibilities here and 6 possibilities here, okay? What is that going to equal to? That's going to equal to 7 plus 7 plus that other, what is that, 13? I'm getting 27. Okay, okay, 27, interesting. Where's that 27 coming from? That's the possible number of outcomes. And what about, we already talked about this, what is this B1, B2, TT right here, the first boy on a Tuesday, the second boy on a Tuesday? That's just a possible, that's just 1, right? Over what? 27, right? And this one's going to be, there's going to be 6 possibilities for this, remember? We talked about it right here. Right there. So that's going to be plus 6 over 27. And this is also the same reason. This right here is that right there. There's 6 possibilities, 6 outcomes there, divided by the total number of outcomes possible, 27. Okay? And that's going to be, this is what we're getting. Look at this. 127 plus 627 plus 627 is equal to, let me make this kind of all big and fun here. Let's see. Let's do this kind of cool coloring here. Let's see. It's equal to, okay, what is that? 13 over, okay, 27. Cool? This is the answer to this problem. 13 27ths. Yes. And you know what else? Yeah. It's less than, it's close to 1/2, what we were insightfully, predicting. But guess what? It's not. It's a little less than 1/2. Okay. Interesting, right? It's between the 1/3, between the 1/2, closest to the 1/2 that we really thought, that I used to think when I looked at this problem, and whenever I even look at it again, I always think, why is it not the 1/2 that it seems like it should be, right? Okay, so that's that. Okay, and I hope you enjoyed the video. And just remember that when you look at this problem, you're basically asking yourself, is it that we're talking about the first one, a boy, on a Tuesday, or any of them is just a boy problem, and you want to know that's given, and you want to know that 2 boys are boys, 2 of them are boys, or are you talking about being given that one of them is a boy born on a Tuesday, exactly what it said here. Look, probability that there's a boy born on a Tuesday. That's exactly what we are left with in the problem, what we did there at the very end. Okay? Thank you for watching.